Okay, everyone, I think we're going to get started because I know we have some students who need to go to 9:30 classes and want them to get to see some of this. So thank you, everyone, for coming out. Thank you to our panelists who I'll introduce in a little bit, and thank you for you all for coming. So what's going to happen is I'm going to start by giving a short little presentation about different career paths in life sciences, different jobs, different ways of getting towards those jobs. But then most of the time it's just going to be open questions and answers. We have a bunch of interesting panelists here and one who will also be Skyping in, covering a variety of fields within biology and medicine, and so hopefully we have some good information for you guys. Starting off by a little introduction to what I know about careers in life sciences, and this is mostly just what I know and my opinions. Some of it might be incorrect, some of it other people might disagree with, and that's great. We can have some conversations about that too. But from my perspective, life sciences is a very wide umbrella. It includes medicine, it includes environmental research, it includes research into fundamentals of biology and biomedical research. It involves teaching, like some of us that do. And the skills that you learn in biology are also applicable to other fields. So people who study biology can land up using their experience using and analyzing data to go into other fields as well. So I know people who have gotten PhDs in molecular biology and now work for Facebook or work for some other company just analyzing big data sets because that's what they're used to doing. And so there are all these different career paths available within life sciences. Some things that are in common between them is that all of these usually require a bachelor's degree, usually a bachelor's of science, in some biological field. And most of these also require some type of advanced degree. Not all, but many. So what I'm going to focus on today is telling you kind of what you should be doing as you're going through your undergraduate career, what at least research grad school looks like, because that's what I went through, so that's what I can speak about. And then we'll let you guys ask questions, and people who have other experiences can share what they've done. So some of the advanced degrees you can get that will push you towards your careers in life sciences. There are a variety of medical advanced degrees available. There are credentials and advanced degrees in teaching. And then there are research degrees, master's and PhD doctorate degrees, which cover a variety of different fields, because you can research in any specialty or subfield that you want, basically. So if you're interested in pursuing one of these careers and you're wondering what you should be doing now at DVC and what you should be doing once you transfer, starting with what you should do at DVC, if you're in a transfer path, so you're planning on getting a bachelor's degree as opposed to, I know a lot of students here have already had a bachelor's degree and are switching fields and are just taking a few classes to go towards a graduate program. But if you're in the transferring group, while you're here, you should do your transfer requirements, the I get C requirements. And those include, especially for scientists, really important classes to take are your ecology and organic chemistry. Those are great things to take here because at DVC we have small class sizes. If you take the equivalent classes at UC Berkeley, there'll be hundreds of people in them, and here they have 30 or less. So it's a good place to be for that. Same goes for physics and for calculus. The core of the biology training here, the introductory classes in cell and molecular biology and ecology and evolution, Bio 130 and 131 are a good thing to get out of the way here. And then there are a variety of other biology classes that can help you choose a career or push you towards the one that you want to be in. So microbiology, anatomy, physiology, genetics, marine biology, oceanography, environmental science, everything we have on the catalog, depending on what you're interested in, some of these will be useful to you, and most of them transfer to your four-year college that you'll go to afterwards. But also very importantly, every individual college, university is different in their transfer requirements, and even program to program, if you want to go to a specific school at UC Davis to study a specific thing, they might have slightly different transfer requirements. So shop around for the programs you're thinking about and look at their specific requirements to make sure you take the classes that will transfer properly to them. Okay? As for thinking about transferring, when you're thinking about what school to go to, I think there are many things to factor in, but two of the most important things to factor in are the expense of the school and the reputation. I think expense is actually kind of a bigger deal here. And expense can vary a lot depending on the school and in your own background. The cheapest way to get a bachelor's degree, if you are low income, your family is low income, is to go to a wealthy private school that has good financial aid. And the ones there that have the best are the Ivy Leagues, and Stanford and other equivalent top tier schools are very competitive, but they also have very generous financial aid packages and can be free for a lot of people. And all of these schools also have websites where you can plug in your income or your parents' income, and it will tell you how much it will cost to go to school there. You'll find a lot of them are cheaper than the state schools. But that depends a lot on your family income. Beyond that, the state schools are the next cheapest option, CSU being the cheapest and the UCs being a little more pricey. And then beyond that, private schools without financial aid are by far the most expensive way. And it doesn't mean that it's not always the right choice. If a program really matches you well and you're going to get a lot out of it, then maybe that's still the path that you should take. But it is something you should consider because there can be a big difference in the amount of debt you come out of undergraduate school with, depending on where you go. Reputation is also an important factor, but it's not the most important factor. And there's another DVC professor, some of you might have had, James Hoffman, who I think has put this really well, that the most important thing about reputation is not the school's reputation, it's your reputation. What you do at the school is much more important than the school you're at. If you take it upon yourself to seek out extra opportunities to work, and if you build good relationships with your professors, if you go out of the way to do things like come to this event, that's a good sign. That's showing that you are invested in your career, and further on down the line when you apply for graduate school or jobs, if people see that you've been taking a very proactive approach to your undergraduate school, it might not really matter what school you attended. So reputation is important, but your reputation is important.
I'll just chime in for 1 second there, because I sat on the graduate admissions committee at Berkeley for many years, and I have to say that we were always more impressed by someone who made the most of their opportunities, who managed to do extra research or something like that outside of their classes, and they came from a small college that maybe none of us have heard of before. We were always more impressed by that than someone who went to MIT and had a research experience there, because I feel like they've had it handed to them, and what we were looking for, people who are self-motivated and able to. So I really want to emphasize that's really what Mark's saying is really true. If you have managed to accomplish something research-wise, whatever, that's much more impressive to us than what school you went to. And we've had many people come to Berkeley, which is a top-tier program, from very, very small colleges, and have been very successful at Berkeley too. So I think that's really true, and it kind of goes against the grain of what maybe many of us have heard before. So
yeah, thank you, Russell. Yeah, I mean, a lot of this comes down to schools want to attract students, and they advertise very heavily on their reputation, so it may seem like it's the most important thing, but your own work, and this is kind of what I was going to get into next, is what should you be doing now and after you transfer as an undergraduate to make you a more competitive candidate for jobs and for schools beyond your undergraduate experience. Of course, you should take classes, you should do well in your classes, you should build good relationships with the professors you take classes from, so that you can ask them for advice or recommendations in the future. And you should use those classes to push you towards your field and decide which subfields you like, because you'll find that you might really like one part of biology and another part doesn't work so well for you. That's fine. But the big advice I would give as an undergrad is to go for experiences outside of class. If you're interested in a research path, find a research lab that you can work in. And I'll talk more about at the end about how to find some of these opportunities, but there are many ways to work in research lab, both as an unpaid volunteer, but also thankfully there are many ways to get paid internships to work at research labs as well. Especially during the summer as an undergraduate is a common time that people do research, so even while you're still at DVC, you can do summer research experiences here in the area. And if you're interested in something other than research, you should do the same advice applies. Go off and find something to do that pushes you towards the thing you want. If you want to be a doctor, something that's accessible to someone who's just an undergraduate is to work as like a medical scribe, which is someone who just follows a doctor around and writes down all their notes for them. And there are a variety of other ways to work and volunteer in a hospital to get a feel for what it's like to be there. Because it's a big investment to go through into the medical profession. So it's very important to both have a good background to say that you have experience and to know that it's actually what you want. Because it can be a very demanding profession. And the most important things about all of these experiences is that you are invested in it so that when someone speaks to you about it, you can show that you understood what you were doing there, that you had good relationships with the people that you worked with there, and you can explain why you did all the things you did. You know, when I was applying to graduate school and I spoke to professors like Russell in our interviews, I would be asked what my research was as an undergrad. And what they're looking for is not just that I did research or that I could, you know, list off a few techniques that I happened to have done, but I actually understood why I was doing those things. So to get the most out of your work experience as an undergrad, ask extra questions. Ask questions of your boss, the people around you, and make sure that you're not just a set of hands, that you actually understand the things you're doing, at least at some level. So that's my advice for as an undergraduate. I'm going to talk now a little bit about just the research graduate programs, because that's what I know about. We have other people here during the question and answers who can speak about some of the medical graduate programs. So in general, there are two categories of graduate research degrees. There are master's degrees and there are PhDs, also known as doctorates. Master's degrees take somewhere from 1 to 3 years. They involve some research, often some teaching, and taking classes. Funding for these varies. Sometimes you have to pay tuition and get in, but there are also a variety of what they would call funded programs, meaning they would pay you to be a student. And there are also many outside grants that you can apply for that could pay for your tuition and pay you a stipend, which is basically a living salary. And master's degrees have a lot of utility. Some people use them as a stepping stone towards a PhD, especially if they feel like their undergraduate experience was lacking or if they didn't get the opportunities to do research they wanted to when they were an undergrad, so they didn't feel competitive to go to a PhD program. A master's program can be a good stepping stone. But there are also many fields that only require a master's degree to work into. Especially kind of engineering fields and computer fields tend to be more common that people just get a master's, and that's true also for bioengineering or biomanufacturing. There are many careers that the PhD can still make you a little more competitive of a job candidate in the future, but is not necessarily worth the opportunity costs of working as a graduate student for extra years. So it depends on what you want to go into, and the best advice for that is ask people who do the job that you want and see if they think a master's or a PhD is appropriate. A PhD degree can vary a lot in time, anywhere from 4 to 8 years, and is longer in the humanities. You take some classes and you do some teaching, but mostly you're working on original research projects. And a good chunk of the actual research work that's done in science is done by PhD students. A lot of the published papers, most of that work comes from the PhD students. PhD programs are mostly funded, and so they'll pay your tuition and you'll get a stipend, a salary, which can vary depending on the school. Is usually enough to live on, but very modest. And so PhDs are important if you're interested in a research career and make you a more competitive candidate for a lot of other jobs. Okay, so a little bit more about the kind of border between PhD and master's, because a PhD is a long program, so sometimes people don't finish their PhDs. And depending on the school, this can work out a little bit differently. At some schools, by making it through your second year and passing your qualifying exams, which are oral exams you take at the end of your second year, that qualifies you for a master's degree. That's what the program I was in at UC Berkeley is like. So we have friends who went through our program who finished with a master's and then went off, either taught or worked in the private sector just with their master's degrees. Other schools, you can kind of declare on your resume you were all but dissertation, which meant that you finished all the requirements for your program, but you didn't finish a dissertation thesis, the final thing you have to hand in for your PhD. And other programs will also let you write a master's thesis, a shorter thesis to give you a master's of science degree. For a perspective of what a PhD program looks like year to year, using the example of the molecular cell biology program at UC Berkeley that I went through, and a number of our panelists went through, the first programs in biology tend to be similar to this, so they'll all have their own little quirks about how they work. The first year tends to involve rotating through different research labs with different professors and choosing a lab that's a good fit for you and has a good research question you want to work on. And usually you also take some classes during that time. In your second year, you're going to start your teaching experiences, so you're going to be a teacher's assistant, and you're also going to take your qualifying exams, which is an oral defense of your proposed research project. You spend many months planning what you think is going to be your PhD research project, and then you sit in front of a panel of experts, professors, who will grill you on it for several hours, and it's a fun experience. Very, very useful experience, though. And then beyond that, you will TA some classes, but you're mostly going to be working on your research. You're going to be following up on your plans and, of course, changing them as they don't work out, which will almost always happen. And you'll be publishing papers. You'll be writing your thesis. And if you have post-graduation plans that are independent from research, this is also a good time to seek out other opportunities. So I was interested in teaching. You're teaching at DVC now. So I sought out other teaching opportunities while I was a PhD student to give me some practice teaching. And if you're more interested in an entrepreneurial route while you're doing your PhD program, you can also start networking and start building the skills and relationships you need for that. And so that's what a PhD program looks like. It is a lot more open-ended than an undergraduate degree. There aren't a set number of requirements you need to finish to get a PhD. It's this more amorphous thing of publish papers, produce a thesis that is satisfactory to your professor and other professors on your thesis committee. But it's a very good experience for learning how to work independently and for learning how research biology really works.